The next skill we're learning today is how to evaluate the derivative from a table of values. And what we want to do in each of these cases is to ultimately find the derivative, but first we have to show symbolically how we're differentiating, and then we're going to plug in the values from the table. So for example, for h prime of 4 in number 1, they give you that h of x equals f of g of x. So this is a composition of functions, therefore we're required to use the chain rule. So the first thing we want to do is symbolically differentiate. So h prime of x is going to be, by the chain rule, the derivative of the outside function, so f prime, leaving the inside function intact, and then multiplying by the derivative of the inside function. You are required to either write this step, or what you can do is go ahead and plug in the 4's. So I could have said h prime of 4 equals f prime of g of 4 times g prime of 4. Then I need to take values from the table. So g of 4, I'm going to come to the table and get g of 4 equals 3. So that gives me here f prime of 3. And then I'm multiplying that by g prime of 4, which is 1. F prime of 3, reading from the table, is 2, so the answer here is 2 times 1, or 2. So let's keep going. K prime of 4 is going to be the derivative of g of f of x at 4, so I've got another chain rule this way in the opposite direction, so I'm going to have g prime of f of 4 times f prime of 4. Then I read values from the table. So f of 4 from the table is 4, which leaves me with g prime of 4, and then times f prime of 4, again reading from the table, I get 3. And then now g prime of 4 is equal to 1, and 1 times 3 is equal to 3. So that's in general how you do derivatives from a table. The next few examples, this one is the product rule, this one is the quotient rule, and then when you go to the next slide, you'll see a power rule, you'll see a chain rule, and you'll see another chain rule. All the way through number 7 use this same table of values. So I'd like you to go ahead and hit pause and then try to do the derivatives from a table on your own, and then check back in a moment to make sure that you got the correct answers. All right, let's go over the responses to these. The first one was the product rule, f times g, the derivative of that at 1. So we differentiate f at 1 times g at 1 plus f evaluated at 1 times g prime of 1. Reading off of the table, we get 1 times 2 plus 3 times 4 is 14. Number 4 is g divided by f, so we need the quotient rule here. So we do low f of 2 times d high, the derivative of g at 2, minus high, g of 2, d low, f prime of 2, and then square the bottom, f of 2, and away we go. And when we sub in from the table, we end up with 0. Now moving on to the next page, the first one is just a power rule. So we have 2 times f prime, and of course negative 3 differentiates to 0. So reading off of the table, we need 2 times f prime of 3, and f prime of 3 is 2, so we get 4. Boy, these numbers are messy. That should have been number 5. So now let's go on to number 6. This one is a chain rule because we have an inside function, f plus g, and then the outside function is raised to the 1/2. So first we're going to bring down the 1/2 and drop a degree to differentiate the outside function, leaving f plus g, the inside function, intact. Then we multiply by the derivative of the inside function, so f prime plus g prime. Now sub in the 2's, so you have f of 2 plus g of 2 in the parentheses here, and then f prime of 2 plus g prime of 2 in the parentheses. And then when I go ahead and add in all of the, evaluate all of these from the table, f of 2 plus g of 2 is 3, f prime of 2 is 4, g prime of 2 is 2, simplifies to 3 over rad 3, which is just rad 3. And then my final one, I have another chain rule. The derivative of m is going to be e to itself, and then multiply by the derivative of your inside function, which is f. Evaluating from a table, I get e raised to the f of 1 times f prime of 1, which gives me e to the 3rd power.